some common properties of congruences. In this video, we'll discuss division, and the result might not be what you'd expect. So far, we have seen how to add, subtract, and multiply with congruences. What about division? There's actually a reason we've waited to discuss division. It turns out that we can't just simply divide on both sides with congruences. In other words, even if we have something like A times D congruent to B times D mod n, that doesn't necessarily mean that A is congruent to B mod n. We can't just simply divide both sides by D. It's a little bit more involved when we work with division. So consider the example. I'm going to erase a little bit here because I'm going to need that later. Consider, for example, 18, which is congruent to 42 mod 8. And you can check this. This is true. Well, 18 and 42 are both divisible by 6. So can we just divide both sides by 6? Well, the question we're asking is, are 3 and 7 equal to each other mod 8? Well, definitely not. They have totally different remainders, mod 8. While this doesn't work, note that 3 does actually equal 7 mod 4. So we divided 18 by 6, we divided 42 by 6, we should also technically divide 8 by 6. But we can't, because 8 is not divisible by 6. However, 8 and 6 have a common factor, which is 2, and we can divide by 2, and thus we get this result here. Will this always work? Well, let's actually check. Suppose we have AD equals BD, and let's try to actually solve this by hand. Well, what does it mean for AD to equal BD mod n? That just means that AD literally equals, not congruent to, but is equal to B times D plus K times N for some integer K. Well, of course, A times D is divisible by D, as is B times D. So Kn must also be divisible by D. Now, if n and d have no common factors other than 1, then we must have that d divides k. But in general, if we try to divide kn by d, we don't know that we will get an integer multiple of n. Some of the n might get divided as well. To be safe, let's divide as much of n as we can when we divide by d. So we're going to take the largest factor of both d and n and cancel that out from n. The rest of the factors of d will come from k, no problem. We will call the largest factor of both d and n the greatest common divisor between d and n. And so we can divide that out from n. So we're going to divide n by d, but not all of d, just the greatest common divisor, because we know that that number can divide out from n. In our example, we showed, we used the fact that the greatest common divisor between 6 and 8 was 2. And so we can divide mod 8, we can convert mod 8 to mod 4 by dividing that 8 by 2, since the greatest common divisor between 6 and 8 is 2. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below, and make sure to click on that subscribe button. All right, let's take a look at what all of this means technically. There's an important result here. Suppose that A times D is congruent to B times D mod n. Then A is congruent to B. You can divide both sides by D. However, the mod changes. We divide n by the greatest common divisor between d and n. If d and n have no common factors, then the GCD between d and n is 1, so A is congruent to B mod n. Let's do an example together. I'm going to erase everything here so that I can pull up the example that I have. We're going to simplify the following congruences using division. First, we're going to work with 24, which is congruent to 39 mod 5, and 24 is congruent to 39 mod 15. Let's start with A. Both 24 and 39 are divisible by 3, and 3 and 5 have no common factors. So 24 is congruent to 39 mod 5. That's just me rewriting the problem. I want to divide both sides by 3, and 3 and 5 have no common factors, so I don't need to change that mod. So I can just divide both sides by 3, and I get that 8 is equal to 13 mod 5. For B, we have, oh, by the way, I mean, you can write that 13 is, well, I mean, we don't have to rewrite this, but we're just showing division mod 5 here. So I'm not going to simplify that 13. Let's look at B. Here we have that 24 is congruent to 39 mod 15. Now in this case, again, I want to divide by 3. However, doing so blindly gives us 8 is congruent to 13 mod 15, which is no longer true. 8 and 13, if I divide both sides by 3, this gives me 8 is equivalent to 13, or congruent to 13 mod 15. That's not even true. That's definitely not true. So I can't just divide both sides by 3. Instead, we must also divide the modulus 15 by the greatest common factor of 3 and 15, which is 3. So again, we get 8 is congruent to 13 mod 5, which is the same result as part A. Anyways, thanks everyone, and I'll see you in the next video.